Hey, now you have learned how to do basic ionic formulas, usually called binary formulas, but I don't like to worry about words like that. But now we need to move on to something that's more complicated. It's called using ionic formulas with polyatomic ions. So let's break that word down. Poly means what? Yeah, something like many, multiple, more than one. Atomic, of course, is atoms, right? And ions, of course, ions. So we're talking about many atoms, ions. So what it's kind of like, these guys, these are different atoms that they always hang out together. They're like these, you have these people in your lives, like friends or whatever, and they're always with a group of people. You never see them without these other people. They have little posses. Well, atoms do the same way. There are some of them that hang out together all the time. And collectively as a group, they'll give away an electron or they'll receive an electron, forming an ion. So, and these are very, very, very common. And so we need to kind of learn some of them. So if you turn to the very back of your packet, so you need to have your packet out, your Unit 4 packet, go to the very back of your packet. You'll see something like this. This is kind of in the middle of your packet. Now, do I need for you to learn all of these? No. I had to when I was a kid, but you don't have to learn it all. What I would like you to be familiar with are the underlined ones. So they're not that bad if you kind of go through them. A lot of them are very common. First of all, there's only one positive. There's only one cation, ammonium. And then a lot of them have these trends. Acetate, carbonate, nitrate, permanganate, sulfate, phosphate. So what do they have in common? Two things. They're all negative, and two, they have oxygen in it. And so then you just kind of say it with whatever the first thing is, like carbonate, carbon with oxygen, carbonate, it's a -2. Phosphate is a phosphorus with 4 oxygens, phosphate, and it forms a -3. Well, now what that means is the phosphorus and 4 oxygens going around in their little posse give away 3 collective electrons in order to be stable. Okay, so let's go back and see how we use these. All right, first of all, okay, so we're going to write the formula the same way you would with single ions, but you just add parentheses if you have more than one. And let me show you that. Well, first of all, let's put these together. Well, magnesium, how would we write magnesium? We would write it magnesium, and it's in group 2. So which ion does it form? +2. Now we have hydroxide. Whoa, hydroxide. Okay, that's not on the periodic table. Let's check to see if it's a polyatomic. Oh, yep, here it is, hydroxide. OH -1. So we're going to go ahead and write that. OH -1. And by the way, if you see just a minus, that assumes the 1. So using what we learned from yesterday, you take the number, cross it down, and so this would be MgOH2. But wait a second, I need 2 of these hydroxides, not 2 hydrogens, this is what this is. This is what this is saying, 2 hydrogens. What I need are 2 hydroxides. So we're going to use parentheses in between to say I have 2 of whatever's in that parentheses. I have 2 hydroxides. So that's how you would write that. Let me clean it up. MgOH2. So that's magnesium hydroxide. Okay, so let's do another one. Ammonium and sulfur. Ammonium. Yeah, that's not on the periodic table, so let's go look here. Oh, ammonium is that only positive one. NH4 +1. And so we have NH4, and it's a +1. And what else do we have? We have and sulfur. Sulfur, of course, is sulfur S, and it's in group 16, so it gains 2 electrons to be stable, forming a -2. Okay, so now we're going to, just like we've done before, take the number, cross it down, NH4. That's the posse that all has to stay together. And if we cross down the 2, we need 2 of them. And then we have 1 sulfur. But wait a second, that kind of looks like 42 hydrogens, and we don't have 42 hydrogens. We have 2 ammoniums. So what do? Put in the parentheses. And this tells you that there are 2 of whatever is in the parentheses. We have 2 ammoniums. 2 of these groups of atoms, 1 nitrogen and 4 hydrogens, that hang around together that like to lose an electron. Okay, next. So that's one way to do that. Let's move on to the slide below it. Some atoms, if you look on your ion table, form more than one. Iron forms a +2 and a +3. Chromium forms a +2 and a +3. And some of these, how do you tell which one it does? It kind of acts one way with one thing and it acts another way with another. You have to look at the Roman numerals. The Roman numerals will tell you what charge it forms. And so for this one, we have iron, Fe, and the Roman numerals tell you that it's a +2. Chlorine is in group 17, so it forms a -1. So if we are going to write this, we cross down the number FeCl2. Okay, iron chloride. And this says we have 2 chlorines for every 1 iron, because iron forms a +2. Now let's say if by chance it said it was Fe3. Well, in that case, then we would need 3 chlorines for every iron. Okay? So that's kind of the difference. So that's why you have to have those Roman numerals to tell you which one's which, because these 2 compounds act very differently. They are different. So you have to know which oxidation state you're dealing with, thus the Roman numerals. Okay, so let's do one quick more before I go. Chromium, chromium +3. So it tells you that you have Cr, and it forms a 3+, meaning it has lost 3 electrons to be stable. And then we have, oh, this thing, that must be a polyatomic ion, multiple atoms acting as an ion. Since it's negative, it has actually gained an electron collectively, so it's kind of gained one. But let's go ahead and write it, NO3, 1-. How do we put these together? Well, again, we're going to cross them down like this. And so now we have Cr1 NO3, but we need 3 of them. Wait a second, we don't need 33 oxygens. That just doesn't make sense. What we need are 3 nitrates. And so we write with parentheses, telling us that we have 3 nitrates, 3 of those what's in the parentheses, for every 1 chromium, because chromium is a +3 and nitrate's only a -1. Okay, so on the back side of this, you're going to have a sheet that has like a big kind of like a grid, and the cations are on one side and the anions are the other, and you're just going to cross them to make compounds. So if you can, go ahead and start working on that as practice, and I will talk to you later. Have a good day.